We are on the back side of 4-2 notes from yesterday, and we're going to be talking first off about special rights. And this, I know, guys, is a review from what we had last year because I just got finished teaching this in Algebra 2. So hopefully it won't be too horribly difficult. What I want you to do real fast is find the length of this right triangle with this angle of 45. If this angle is 45 here, what's this going to be? 45. And if two angles are the same, then their corresponding sides are also the same. So let's find this hypotenuse given these two sides. So I have 1 squared, which is 1. 1 squared, which is? 1. Okay, class, really? Here we go.
1.
What's 1 plus 1? 2. Good job. So now I have 2 equals c squared. How do I get to c? Okay, so this becomes the square root of 2. Okay, this becomes the square root of 2. And we found that just using Pythagorean theorem. So what I want to do is show you, remind you would be a better way to say that, the little gimmick that we have with 45, 45, 90 degree triangles. So with the 45, 45, 90, when the side is given, and it doesn't matter which side because the sides are equivalent on a 45, 45, and I want to get to the hypotenuse. Side is given, and I want to get to the hypotenuse. Let's just take what we have. If the side is 1, what did I multiply by 1 to get to the square root of 2? To get to the square root of 2.
1.
What do I multiply by 1 to get to the square root of 2? I multiply by square root of 2. Anything multiplied by 1 is itself, okay? Now, let's do the reverse of that. If the hypotenuse is given, and I want to get to the side on a 45, 45, so for instance, if square root of 2 is given, and I want to get back to 1, I'm just going to do the reverse. So I'm going to divide by root 2 on a 45, 45, 90. Okay? Now, I'm not going to take the time. You guys can do this on your own like what we did at the end of yesterday. And I'm going to have you fill in all 6 trig functions. And just so that we know, when I say 6, sine, cosine, tangent, cosecant, secant, and cotangent, all 6. On here, all we're doing is finding just the ratios, setting those up. All right, so I'm going to move on to the next special right, which is a 30, 60, 90. Again, using Pythagorean theorem, I'm going to find the missing side. But unfortunately, I have 1 squared plus, I don't know what that side is, b squared is going to give me c squared, which is 2 squared. So b squared, that's 4 minus 1, is going to be 3. So b ends up to be the square root of 3 using my Pythagorean theorem. And giving a 1, 2 square root of 3 triangle, or actually 1 square root of 3, 2 triangle, we also have special little gimmicks on a 30, 60, 90. So, given a 30, 60, 90, and back in the day, and maybe it was just last night, you know, actually it was kind of rainy, so I doubt that it was last night. Maybe it'll be tonight. You guys get a neighborhood game of good old tag playing, or kick the can, or capture the flag. Any of those types of games has a what position that you want to get to, and then nobody can touch you. Or you get to that spot and you can free anybody that had already been captured. What's that generic term? You want to get to base, okay? You want to get to home base, all right? If you get in home, get to base, then it's like a free spot. Nobody can touch you. In a 30, 60, 90 degree triangle, this is a really crappy analogy, by the way, but stay with me here. On a 30, 60, 90 degree triangle, we also have a home base. We've got a base that we want to get to, and it's the short side. because everything comes from the short side on a 30, 60, 90 degree triangle. So if you have the short base, you can easily get to hypotenuse, you can easily get to the medium side. And if you got the hypotenuse, you don't have short base, you're going to go hypotenuse to short base to medium side. Everything comes from the short side. So for instance, short side here is given. So from the short side to get to the hypotenuse, I'm going to multiply by 2. From the short base to the medium length side, I'm going to multiply by the square root of 3. And how do I recognize short base? Short base is because it's always opposite the smallest angle. Small angle creates small side. Large angle creates large side. So our 30 degrees, it's always opposite of 30 degrees. So our shortcut is always start with the short base. So if the short is given and I want to get to hypotenuse, I'm going to multiply by 2. And you can see that here on our example. On the short side, to get to the medium side, I'm going to multiply by square root of 3. Oh, gracious, but what if the short side's not given? Then hopefully maybe the hypotenuse is given. And to get to the short side, perfect, divide by 2. Oh, gracious, the hypotenuse and the short side are not given, but the medium side is. I still go to the short base. Divide by square root of 3. You will never go from hypotenuse to medium or medium to hypotenuse. Everything is in reference to home base. You want to get back to home in order to find the other side. And so there's our options that we might have. And if you notice short is involved in every single one of them. Okay, so that's my little shortcut on my 30, 60, 90 degree triangle. So the next two that you need to fill out, one you're going to find the ratios in reference to 60 degrees, and the last one you're going to find in reference to 30 degrees. And again, I'm going to let you guys do that on your own, and we'll check them tomorrow. Okay, so let's look at these examples down below. This first example says a right triangle with a hypotenuse of 5 inches includes a 43-degree angle. 43 right there tells me automatically I do not have a special right. So I want to find the measurements of the other two angles and the lengths of the other two sides. So the first thing I'm going to do is draw myself a picture. It's a right triangle, so I need to include a right angle. Hypotenuse is 5 inches, and I've got a 43-degree angle. Really, it doesn't matter if your 43 is down below as an angle of elevation or if it's up top, which would be called the angle of depression. But it doesn't matter on this particular case. In fact, even if you put it up here, you'll use a different trig function, but we'll get the same answers, okay? But I'm just sticking it down here just because. All right, so I'm looking for my other angles. All right, so I'm just going to say this is A and this is B because 5 is C. So if I need to find side A, since A comes before B, A in reference to angle 43, in reference to the 43 degrees, A is what side of the triangle? Adjacent. So I have adjacent over hypotenuse. What trig function is that? Adjacent over hypotenuse. So I'm going to say cosine of 43 degrees is adjacent over hypotenuse. Now I'm going to take a second. I'm going to do a little squirrel chasing. But this is very, very, very important that you guys understand this. That any time that you're using a trig function, sine, cosine, tangent, even cosecant, secant, and cotangent, anytime that you're doing a trig function, the proper way, number one, we say sine, not sin. We say cosine, not cos or cos or whatever it is that everybody says. Tangent, not tan. If you do those abbreviations, you're actually showing your, I really don't know what I'm talking about. And you guys do know what you're talking about. So be educated, be intelligent when you're speaking this. sine, cosine, and tangent. It takes a millisecond to say the extra syllable on that. The other thing that's common is that it's sine equals 4/7, or whatever the ratio is. If sine, cosine, tangent, cosecant, secant, cotangent do not have an angle measurement after, you have, well, number one, it'll be wrong, but you have misrepresented a trig function, because it's always the trig function. Immediately following the trig function is an angle measurement, because that's exactly what these trig functions are. It's finding the sine, cosine, tangent of an angle, and then that's the ratio of the comparison of the sides. So always sine, angle measurement equals something. Cosine, angle measurement equals to something. Tangent, angle measurement. And even if the angle measurement isn't given, then you're writing either A, B, C, whatever the angle is, or theta. You can always throw theta in there. Okay, so make sure that you're writing it appropriately as well. Okay, not only speaking it, but that we're writing it appropriately as well. So I have cosine, angle measurement equals to something. And now this is an algebraic problem that we saw at the beginning yesterday with our warm-up that Eddie took us through. No, Eddie didn't teach us that yet. I think I did that first, and then you came in. So if I want to get to A, what do I do to both sides? Multiply by 5. So I get 5 cosine of 43 degrees equals A. At this point in the game, your calculator should already be in degree mode, and you want to double check to make sure that it is. And if it is, then you just type that in exactly as it is, and you will find A to be 3.66 inches. And since my unit of inches is given, I represent that in inches as well. Go to mode, and then just make sure that you're in degrees, not radians. Because otherwise you will not get this measurement if you're not in degree. Okay? So now let's look at B. And again, I'm looking at B in reference to the angle 43 degrees. So side B is which side? If this is adjacent, B becomes opposite. So which trig function is opposite over hypotenuse? Sine.
Wait, can't you just do Pythagorean theorem to find B? Would it be easier to use cosecant?
Sine is B, sine of what? Look here, I'm talking about the angle measurement and I didn't even do what I said. Is B over 5. Okay, I have a couple different questions going on. First was, couldn't we just use Pythagorean theorem? 100%, absolutely you could. But you, instead of typing in 43, your finger slipped and accidentally typed in 44. And so you didn't quite get this. By using this value to find this value, what have you done? You've messed up both now. My suggestion is, I will not count it wrong if you don't, if you continue to do, like if you want to use Pythagorean on, that's not wrong. But if you want to be 100% accurate, you go back to the original, what was originally given to you. Okay? So that's why I would choose to use the other trig function opposite over hypotenuse on that. Okay? So then, looking for B, again, I multiply both sides by 5, so I get sine of 43 degrees is B. Type that strictly into your calculator. And actually, I think the trig function, by the time you're got decimals with Pythagorean theorem and all that, this is much simpler and less to type in than doing that's just my opinion. And you should get 3.41 inches on that. Okay? Typing that in exactly. Now, two angles are given, the 90 because it's specified that it's a right triangle, and then it also specifies the degree of 43. I want to find this angle. So, knowing that all three of these add up to be how much? 180 minus the first angle that was given, minus the second angle that was given, leaves me with 47 degrees. That is the basis behind all three angles adding up to be 190, or 180. Some of you might want to add that and then subtract. Some of you just take 90 minus 43 to get to that. All of those are perfectly acceptable. Okay, so questions on any of that? We good? Okay, next one. Locate above your sine, cosine, tangent button, a button that looks like, or a function, sine to the -1, cosine to the -1, tangent to the -1. These are called inverse functions of sine, cosine, and tangent. If you have spaced out on me through this entire lesson, but you're feeling like, okay, I better pay attention, yes, now's the time to really, really pay attention. Sine, the inverse sine button, sine to the -1, cosine to the -1, tangent to the -1, only used to find an angle. These are not, because one of the main mistakes is that if you were to calculate cosecant, secant, or cotangent, thinking that those are inverses, they're reciprocals of sine, cosine, and tangent, these are not the buttons that you use. In fact, you would literally have to type the reciprocal in to your calculator. There's not a cosecant, secant, or cotangent button. These are only used to find an angle measurement, okay? Strictly for angle measurement only, all right? So knowing that, we want to find the angle measurement of this right triangle right here. So I can either look at it in terms of angle A, or I can look at it in terms of angle B. Do we have a preference? A? All right. So in terms of angle A, I'll label that theta. I don't know what the angle measurement is, but that's what we're looking for. 4 becomes what side? Opposite, and 7 becomes adjacent. Which trig function is opposite and adjacent? Tangent. So I know that tangent, we're looking at it in terms of angle A, so I'll say A. Tangent of A is 4/7. Okay, you might be able to skip that step if you want to, but I just want you to know that we are looking for angle A. So in order to find my angle, I'm going to change my function to inverse. So I'm going to take the inverse tangent of 4/7, that will give me angle A. Now, using the inverse tangent button, I type in inverse tangent of 4/7, and you should get 29.74 degrees. And then I'm to find the other angle. Find the missing angles is my direction. So I need to find this other angle. I could take my 29.74, subtract n90, and subtract from 180 to get my third angle. But again, had I made some slip of a, pushed in the wrong button or whatever, I would end up with the wrong answer. So you want to know that you know that you know, you've got it right. Now I'm going to use tangent of angle B is now opposite over adjacent. So 7 now is my opposite side, 4 is my adjacent side. I'll do the exact same thing. So inverse of 7/4 is going to give me angle B. And B should be 60.3 degrees. I will not take off any points should you just subtract all that. That's okay. But just know that you're rolling the dice on that, assuming that that's correct, because then they both will be wrong. Okay? So that's just kind of the gamble on that. Okay, so the last example that we have, and then you guys will have some time to finish the top. Angle A is 35 degrees, so I'm going to go ahead and mark that as 35 degrees. Side A is 11. Okay, in this section, we're not going to have a ton that are going to be not labeled as this triangle is, but in a couple sections coming up down the road, every single triangle you're going to have to label yourself because it's going to be given just like this written out. Please know that it is opposite the angle that is written. So if angle A is here, side A is over here. Side A is opposite angle A. Side B is opposite angle B, and side C is opposite angle C. That's how you know that you've set it up appropriately. You cannot just say, oh, I don't care where I put it, I'll just put it wherever. That is incorrect. When it's given as angle A and side A, they are opposite one another. Okay? And so now we're trying to find all the missing sides and all the missing angles. So I have side A, that would be angle A right here, angle A of 35 degrees. Do I want to solve for B or C first? B, okay. So we'll solve for B. So I have opposite and adjacent. We got tangent again. So I take tangent of 35. Don't forget that angle measurement goes right after the trig function. Opposite over adjacent. This is like number 5 on our warm-up. Algebraically solving, we have to multiply by b from both sides and then divide by tangent. So I get b equals 11 divided by tangent of 35. So on your calculator, you take 11 divided by tangent of 35, and you get 15.71. There's no units written on here, so I don't know what the unit measurement is, so I'll just leave that off. And then I'll do the same thing with C. And again, Pythagorean theorem will work, but if I want to make sure that I'm doing it correctly, I will use my trig function again. This time I'm opposite over hypotenuse, which is sine. So I'll do sine of 35 equals 11 divided by C. C's in the denominator, multiply that by both sides, divide by sine of 35. And C ends up to be 19.18. And then whatever method you like to come up with your third angle, you could take 90 minus 35. And you get 55 degrees. Okay? So there's our solving that we have. And down below, you've got 4 different calculator errors evaluating trig functions. The first 2 are probably the most prominent that we see, you know, with our quizzes and whatnot. Not checking to make sure that you're in degree mode, and then making sure that sine to the -1, cosine -1, tangent to the -1, those inverse functions are only used to find angle, not cotangent, secant, and cosecant. Okay, so some common mistakes you want to pay close attention to. Lastly, the homework that's on the back is not the same as the homework on the front. You need to combine them, okay? That is one. So this homework on the front is what you could have done given the information on the front page. The homework on the back is the homework that you can do given the information on the back page, okay?